Hello everybody, Geometry CP1. This is Unit 4, Lesson 2. End of this lesson, you'll be able to do the following. Identify right, acute, and obtuse triangles. Define scalene, equilateral, and isosceles triangles, as well as define trapezoid, kite, parallelogram, rhombus, rectangle, excuse me, and squares. Without further delay, let's get started. Okay, let's start with classifying triangles based on their angle measures. So a right triangle is a triangle that contains exactly one right angle. Okay, now a triangle can't contain more than one right angle, otherwise it wouldn't be able to be a triangle. Okay, so you can see in these diagrams here, I got a 90, I got a 90. These are special right triangles. This is a 45, 45, 90, 30, 60, 90. But you could also have a triangle that's a right triangle with a 90 here, and let's say an 80 and a 20. Oops, not a 20. That wouldn't work. How about a 10? That 10. That works. Okay, so that's also a right triangle. So I don't have to have that right angle labeled as 90. We could also use this little square in the corner there to represent that right angle. An acute triangle is a triangle with exactly three acute angles. So we've talked about acute. An acute angle, let's call it theta, is an angle where the measure of theta 1, where the measure of theta, angle theta, is less than 90 degrees and greater than 0 degrees. So the measure of any acute angle we call theta is between 0 and 90, non-inclusive. Okay, now an obtuse triangle is a triangle with exactly one obtuse angle. Obtuse angle. For example, we've got this 130 degree angle here. If you have an obtuse angle, that will guarantee that your other two angles will be acute. So will an acute triangle, right? We'll have three acute angles, and a right triangle will have two acute angles. An obtuse angle, by definition, in an obtuse angle, let's call it phi, it's a Greek letter, getting smart here, would be between 90 degrees and 180 degrees. Okay, so the measure of that obtuse angle phi would be between 90 and 180. Okay, let's continue with more on this topic. All right, let's classify triangles according to their side lengths now. So a scalene triangle is a triangle with no congruent sides. All right, so each of the sides has a separate measure, not equivalent. Example, 5 and 4 and 3. Okay, that would be a scalene triangle. Equilateral triangle would be a triangle with 3 congruent sides. All right, so for example, in this triangle here, that would be if we had side lengths of 10, 10, and 10. Now, an equilateral triangle also has equal angle measures. So an equilateral triangle would also be equiangular, which would make it a regular triangle, which we call equilateral. Isosceles triangle is a triangle with at least 2 congruent sides. So here I could have measures of 12 and 12. That would make this side length different. I don't know what it would be, but maybe 10. How about that? An isosceles triangle has base angles that are congruent and a vertex angle that is different. Okay, that's the definition of, or that is the classification of triangles based on their side lengths. Let's continue. Now, we've already talked a little bit about the properties or parts of an isosceles triangle. Let's review them. This angle right here is the vertex angle. Here I have the base side length, right? It's this side right here. These two angles are called the base angles. And these two sides are called the legs. Okay, let's talk a little bit more with isosceles triangles. Okay, putting triangles behind us, let's talk a little bit about quadrilaterals. Looking at the following, I see a trapezoid. A trapezoid is a quadrilateral. I'm going to refer to it as just quad for now. With exactly one pair of parallel sides. You can see them right here. That side's parallel to this side. The other two sides are not. One pair of parallel sides. Okay, a kite is a quadrilateral with two distinct pair of consecutive congruent side lengths. Okay, so for example, take a look here. I've got these two sides, which are consecutive sides that are congruent. That is a distinct pair from these two sides, which are consecutive congruent sides. So if I had a quadrilateral that looked like this, this would not be a kite because the sides that are congruent are not consecutive sides. Okay, so this would not be a kite. No, not a kite. We're going to talk about this type of quadrilateral in a moment. Parallelogram. A parallelogram is a quadrilateral with two pair of parallel sides. All right, so I can see, and actually I should have an extra arrow to distinguish that those two sides are parallel as well as these two sides are parallel. So two pair of parallel sides. Let's continue. More quadrilaterals, very fun. A rhombus is an equilateral quadrilateral. I'm just going to shorten that, but an equilateral quadrilateral. So look at that. 1, 2, 3, 4 congruent side lengths. However, we don't know that the measure of all four angles are the same. So we can just say it's an equilateral quadrilateral, not an equiangular quadrilateral. Now the rectangle is the equiangular quadrilateral. Okay, you can see 90s in all four corners. The square is the combination of those two. The square is what we'd call a regular quadrilateral. Regular meaning both equiangular, oh gosh, and equilateral. Lateral. I'm not spelling very well, but you get the point. All right, you can hear my voice. All four sides the same, all four angles the same. That's a square. All right, let's continue with our last slide. So here you can see the breakdown of the family of quadrilaterals. Okay, so we can see that with one pair of parallel sides, we have a trapezoid. With two pair of parallel sides, we actually have a number of options here. Let's get back to that in a moment. No pair of parallel sides, I have the kite. The kite is a quadrilateral with two distinct pair of consecutive congruent sides. That was kind of the oddball in our definitions when we talked about how do we define a kite as opposed to a rhombus or a square or a trapezoid, right? That was the only one we talked about consecutive congruent sides. So it kind of sits out there on its own. Okay, the trapezoid, like I said, one pair of parallel sides. The most generic definition of a quadrilateral is that a quadrilateral has four sides. A more specific example of a quadrilateral is a parallelogram. Now, when we talk about parallelograms, there are three types of parallelograms: rectangles, rhombuses, and squares. Now, as we go further down in the tree, the number of different ways to classify, or the number of attributes of which that quadrilateral contains, becomes more complex. So a parallelogram is just two pair of parallel sides. That's the symbol for parallel. Okay, now that applies to all quadrilaterals beneath it. Plus, a rectangle is equiangular, as well as has two pair of parallel sides. A rhombus is equilateral, as well as having the properties of a parallelogram. And a square has, again, the properties of parallelogram as well as rectangle and rhombus. When we combine equiangular and equilateral, of course, that is regular. A regular quadrilateral. So the square takes on all properties of every four-sided figure above it within the tree. And of course, the quadrilateral is the granddaddy of them all. Okay, all four-sided shapes, kites, trapezoids, parallelograms, and all beneath the parallelogram in the tree are all considered in the family of quadrilaterals. All right, guys, that's it for this lesson. We'll see you in the next video.